Okay, so we're going to go through this problem. We're going to find the indefinite integral. Now, remember, indefinite means no bounds. So, therefore, at the end of the problem, we're going to need to have plus c. All right, so moving along. Now, this problem here, I'm seeing a bit of chain rule, right? I'm seeing 8 raised to a 2x, not just an x, to a 2x. Same thing, e raised to a 9x. So I'm seeing some chain rule. Now, we don't know how to do chain rule backwards, so this is where we use u sub. Now, I might use a different u for each of these problems. So remember, just like derivatives, that was supposed to be an 8, just like derivatives, we can think of each term as its own individual problem. Let me make this plus just a little over here. There we go. Plus the antiderivative. Now, this one I'll do a quick little rewrite. Having that in the denominator is not one of our basic rules. Actually, I'm actually not going to do a rewrite. I like having x in the denominator for this particular problem. We'll see why. All right, so now I have 3 separate problems, so I'm going to look at them individually. So looking at this first one, 8 to the 2x, I'm going to say, all right, what would u be? Well, in this problem, I don't know how to do 8 to the 2x, but I do know how to do 8 to the x, right? That would be a basic rule. So I'm going to let 2x be my u. So therefore, du would be the derivative of this. So that would be 2 dx. Now I'm looking for a substitution. All right, so we have 2 dx. In my problem, do I have a 2 multiplying my dx? No, I don't. I have just dx. So I'm going to use the inside-outside technique. I'm going to put a 2 in, multiply by 2, but I can't just multiply by 2. I also have to divide by 1/2. That keeps it balanced. So notice I put the multiplying by 2 inside the integral, and I put the 1/2 outside. So now I have my perfect substitution. So this is going to be 1/2 antiderivative of 8 to the u, right? Because everywhere I have a 2x, I'm going to replace that with u. So my 2x became u, okay? So that's going to leave us with 8 to the u du, because everything that was yellow got subbed out and turned into du. And there we go. So now that first antiderivative is ready to go. This is a base rule. So now we move on to the next one. So plus. All right, so now this kind of stuff, we're going to say this is kind of dead to me. We don't need this anymore. So we're going to move over here to this next problem. Now, on your test, please don't erase it. Leave that there. But here, we're going to say, okay, now I need something else. Maybe, and it's going to be the same logic. I have my exponent that I want to make just u. So we're going to say u equals 9x. Now, if you had u over here, we probably don't want to reuse the same letter. So u is just a generic substitute. So we're going to call it w, right? We can call it w. Or any letter. You can make it a happy face. It really doesn't matter. So w equals 9x. So therefore, dw is equal to, actually, let me put this u back. I don't want to lose it. So that's u equals 2x. So therefore, du equals 2 dx. Okay. So now, the derivative of 9x would be 9 dx. So everywhere I have a 9 dx, I'm going to replace that with dw. Well, I have a dx, but I don't have a 9. I have a 4. All right, so first things first. Let's just move this 4 to the outside. Okay. Oops. And now I need to put a 9 in. So inside-outside technique says put a 9 in, but put a 1/9 out. And now I have a perfect match. So 9 dx will become dw, and my 9x will become w, leaving me with, on the outside, 4/9 times the antiderivative of e raised to the w dw. Now, last but not least, this one, I'm going to take this 11 and move it outside. I always think it's so much easier. I think it's so much easier to take your constants and move them out, because then it makes the antiderivative much easier to see. So what is the antiderivative of 1 over x? Well, that's a base rule, right? That's just the natural log of x. And now we're almost done. I'll put the plus c, but that plus c will just absorb all the constants from all of the antiderivatives. Or if you wanted to do it all at once, you absolutely could. You could say, look, you could say, look, I'm just going to leave this as 1 over x dx, and then now I'm going to do all my antiderivatives in one step. So we're going to have 1/2 times, what is the antiderivative of 8 to the u? Well, the exponential rule is 8 to the u divided by the natural log of 8 plus 4/9 times, what's the antiderivative of e to the w? Well, that would be e to the w plus 11 times the natural log of x plus c. There we go. One constant for all of them. Now, with the very last step, we just say to ourselves, I didn't start with u, I didn't start with w, I did start with x. So I need to substitute back in. So everywhere I have a u or everywhere I have a w, I have to substitute back in what they actually are. And if you want to, you could also multiply like the 1 and the 2 in. So this would give me 8 to the 2x divided by 2 times the natural log of 8 plus 4e to the 9x divided by 9 plus 11 times the natural log of the absolute value of x plus c. All right, I hope that helps.